too. So first of all, let's just get down one vocabulary word. In your math journal, fresh new page, equivalent fractions are basically fractions that represent the same number. So looking at this visual here, you're going to notice these 4 different circles. The red one represents 1/2, of course. You're going to see that 2/4 is another way to say it, but it's equivalent to 1/2. Same thing with 3/6 and then 4/8. So now let's think of a really familiar fraction. We have 1/2 here, and these are just more visuals just to sort of help you see how 1/2 is also equal to 2/4. And we have these little fraction bars here. First we saw how it was split into 1/2.
Sorry, I'll back up. Okay.
And then you're going to see that when we add some more sections here, now it's broken up into 2/4.
Yep.
And so, yes, here we have 1/2, like half of the bar is equal to these 2/4 as well. It's also equal to 3/6. So then you're going to see here, once again, we're broken up into a half, but then it can also be broken up into 3 of these sixths. Then once again, we have 4/8, and we can see here, here's originally our 1/2, and then we have our 1, 2, 3, 4 eighths out of this 1/2. Lastly, we have 5/10 as well. So if we break up this whole bar into 10 equal pieces, then 1/2 is also equal to 1, 2, 3, 4, 5/10.
And what we made there is called a equivalent fraction chain. So if you think of them as being kind of linked together because they're all equal, that's what these are all. That's what that's called, is a chain. So if we ever refer to that, that's what we're talking about. Okay, so we are going to make even more that are equivalent to 1/2. As long as you multiply the numerator and denominator by the same number, you're going to get an equivalent fraction no matter what. So it could be something like multiplying them by 8. So if I multiply numerator and denominator by 8, you get 8/16, and those are still equivalent. Okay, that's sort of a smaller one. You could multiply it by 100. So if I have 100, or 1/2, and I multiply the numerator and denominator by 100, 100 2/100ths. Still equivalent to 1/2. Okay, so no matter what, as long as you do the same thing to the top and the bottom, then you are good to go, and you have an equivalent fraction.
All right, just another way to think about equivalent fractions. If you have a multiplication table, you're going to notice that we have, if we look just going across at this row of 3 here, row 3 actually shows multiples of 3. We're just skip counting 3, 6, 9, 12, and so on, all the way down the row. So these are just different multiples of 3, and then if we do the same thing, multiples of 5. So once again, we're just sort of going across this row here, skip counting by 5s, and seeing that we basically can make one of those equivalent chains by just thinking of this row 3 as all of our numerators and row 5 as all of our denominators. So what are some equivalent fractions to 3/5? If we started over here and we said, okay, well, I have 3/5, then that can also be equal to 6/10, or 9/15, or 12/20, 18/30, and so on, all the way down to 30/50. And really, if this multiplication table kept going, we could just keep going and going and going. But this is just another one, another way to find like an equivalent chain of fractions.
And the reason is because you're multiplying the numerator and denominator by the same thing. So in this, you're multiplying them both by 7, and so on.
So now what we want you to do is just pause for a moment and make a fraction chain using row 4 and row 7 as your numerator and denominator.
So you'll start, your first fraction in your chain will be 4 7s, and then you'll just do equals, and then you'll just go on out using the table.
Yeah. And, oh yeah, so pause, do that. And then here is what you should have come up with. Basically, you're just looking up here again and doing that. But once again, we just want you to think about how, yeah, you're multiplying both the numerator and denominator by 2, and then by 3, and 4, and so on, all the way up to 10.
Alright, so now we are going to work on finding equivalent fractions going the other way. So we found them by multiplying and making the numbers bigger. Now we're going to talk about finding equivalent fractions by dividing and making them smaller. And what this is actually called is simplifying. You're going to just learn to love to simplify fractions. Let's hope. We'll cross our fingers. So to simplify fractions, we're going to have to, again, use a lot of things that we've already learned. So here are a couple of examples, and you're definitely going to want to write these down and all the steps that it takes to get to them. So for the first one, 12 and 18. So 12 eighteenths. The first thing I'm going to think in my head is, okay, do they have any factors in common? So if we think back to our little factor rainbows, what factors do those have in common? And I think, 6 goes into both of those. And I think that's the biggest one. So I'm going to actually, instead of multiplying both of these by 6, I'm going to divide them both by 6. So what happens when I do that? 12 divided by 6 ends up being 2. 18 divided by 6 ends up being 3. So I have now simplified 12 eighteenths, and it is now 2/3. But those two are equivalent. Okay? So again, we're just sort of working backwards. So now I've got 10 and 15. So in my head, again, I'm thinking of those factor rainbows, and I've got 5. I know it was in both of those. So I'm going to divide them both by 5. And again, just like you have to multiply numerator and denominator by the same exact thing. Same thing with dividing. I couldn't divide this by 10 and this one by 5. That wouldn't work. So divide those both by 5, and we end up with 2/3 again. So 12 eighths is equivalent to 10 fifteenths is equivalent to 2/3. So now try these two on your own. We're not going to show you these answers, so try these two on your own. We want you to simplify. Oh, 3. Just kidding. Take 9/30ths, 20 25ths, and 16 32nds, and try to simplify them. So find out what you could divide both the numerator and denominator by. And we'll go over those tomorrow. And then I think there's just one more thing.
Yeah, yep. Oh, and I was just thinking, going back, sometimes thinking about simplifying, sometimes we might right away see that they're both even numbers, and so you might think, oh, I can divide by 2.
Yep.
And that's true, but just double check, because you might be able to divide by 2
do it
again.
Yeah.
Or even again. So just be careful and keep double checking, see if you can simplify or if you're truly done.
Yep.
Okay. So anyway, last scenario here. What if we want to change 5/8 to a fraction, and we already know that the denominator is 24? We just have to solve for n here. So applying what we've just been learning about, n is unknown for right now, but what we just have to think about is, okay, we see our 8 here, and it's eventually going to equal 24. What do I have to do to get it to equal to 24? Well, I know that 8 times 3 equals 24, and we've been really specifying over and over and over again that whatever you do to the denominator, we have to do to the numerator. So you have to multiply the numerator by 3 as well. So n should now equal 15 instead of n.
So 5/8 is equal to 15 24ths. They are equivalent.
And so now we just have a couple more problems for you to do. And some of you might be thinking, oh, look at all these problems. But really, you're just solving for either n for numerator or d for denominator. So please make sure to rewrite like the whole problem, though, so we can sort of see where you started and what you got. It's easier for discussion and going over in class. So remember those, and good luck.
I throw my hands up in the air sometimes, saying,